We are now looking at projectile motion. Projectile motion. Projectile motion, and we shall say that this is the motion of a body which, after being given an initial velocity, moves under the influence of gravity. Full stop. Then we say, so that's the definition here. They can ask you to define the projectile motion. Projectile motion is the motion of a body which, after being given an initial velocity, it moves under the influence of gravity. Then next you say, a projectile is a body. A projectile is a body which, given an initial velocity, it moves under the influence of gravity. So they can ask you to define projectile. You say it is a body, don't say it's a motion. Then they can ask you to define projectile motion. In the projectile motion, you say this is the motion of a body. Then projectile is simply a body which, when given an initial velocity, it moves under the influence of its weight. Okay? Or it moves under the influence of gravity. So we are going to say, consider a body projected at O. Consider a body projected at O with an initial velocity u. With an initial velocity u at an angle theta to the horizontal. At an angle theta to the horizontal. So we have this one. So this is y, this x-axis, this is y what? Axis. So the body is projected from O, like that. So it is given an initial velocity. This is the u at an angle theta to the horizontal. Then from here we shall now say here, we shall say, now here we have something like this. Okay? Then we have here theta. Here we have the resultant, which we could call it u. And then we want to get this. Let me call this one. I call this one y. I call this one what? X. So now I want to get the components. There's what we call horizontal component of this velocity, horizontal component, and want to get a vertical component of the velocity, because the velocity is a vector quantity which is expressed in terms of its magnitude and direction. So we need to know the size of that velocity under horizontal direction and under vertical direction. So if I say sin theta opposite over hypotenuse, which is u. So meaning that y will become, this is u sine theta. This is vertical what? Component. Then the cos theta will become x adjacent divided by hypotenuse. So we shall say that x is equal to u cos of theta. This is horizontal component. So here we shall have that component of u sine theta. Then here we shall have u cos of theta. Okay, is that okay? Then we shall come and say, we look at the terms involved. Okay? We can say, let us look at the terms involved. Now, this one here, we shall call it, from here to here, we shall call this one H, capital H, maximum, not so. Now, here we shall call this one before hitting the ground, before the projectile hits the ground. It has Vy, Vx, sorry, that's under horizontal direction. Then under vertical direction, we shall have what? Vy Okay? So before hitting the ground, it has the final velocity. This will be the final velocity in that direction. The final velocity, we can call it V. Now, since this is a resultant of the two velocities, it means that there must be direction with alpha to the horizontal. Direction what? Alpha to the horizontal. So we start with the first, the terms involved, okay? Terms what? Involved, or terms used. So terms used. One, we're going to start with the maximum what? Height. Then we look at the maximum. Maximum, that is H what? H maximum. So under maximum height, what are you seeing there? We know that at the maximum height, okay, the final velocity V is equal to what? V is equal to 0. Okay? At the maximum height, V is equal to 0. So shall we say that V squared is equal to U squared minus 2G what? 2Gs, okay? We substitute. But then our Uy under vertical motion will be equal to U sine of theta. So we substitute 0 squared is equal to U squared sine squared theta minus 2GH max. So what will be our H max? H maximum will not become U squared sine squared theta divided by 2G. That's 1. 2. Time to reach maximum height. Time to reach maximum height. We shall say that V equals U minus G T. Okay? But our V is equal to what? To 0. Okay, so our 0 will become, but this is vertical motion. In the vertical motion, the vertical component of velocity is U sine. So it is U sine of theta minus G T. So what will be our T? Our T will become U sine theta divided by what? By G. Like that. Is that okay? Then let us remove this one now. That's 1. Then we move on. Okay? We move on and get time to reach the maximum height. We have gotten it. It's that one. Then let us go to what they call time of flight. Time of flight. Time. Time of flight, we shall say that is the total time taken by the projectile. Is the total time taken by the projectile by the projectile from the point of projection, from the point of projection to the point where it lands, to the point where it lands the plane. It lands the plane through the point of what? Through the point of projection. Through the point of what? Projection. Through the point of projection. So we are saying that if the ball is kicked from here, okay, maybe in a pitch, and then it moves under this projectile path, and then lands here, the total time taken for the whole journey is time of what? Right. So let us get the time of what? Right. So we can say time of flight. So we shall now say at the point, let me say this is A. At the point A, distance y is equal to 0. When the ball has landed on the ground, the vertical distance becomes what? 0. Therefore, we shall now say that y is equal to ut minus a half gt what? Squared. Okay? So this will be 0 equals u sine of theta times time of flight, we shall use capital T minus a half gt squared. So that means that a half gt squared is equal to u sine of what? Theta. So t will cancel, our t will become 2u sine of theta divided by what? By g. But time to reach the maximum height, to reach what? To reach maximum height, to reach h maximum is equal to, we've already seen it as u sine of theta divided by what? Divided by g. So when you compare the two, you realize that this is half of this one is twice the other one. Therefore, t is equal to 2 what? T, implying that time of flight is twice time to reach the maximum height. To reach the maximum height. To reach the maximum height, like that. Then I can move this one. We continue with the same diagram, and we got what they call, after that, we can look at range. Here, I didn't indicate it there, but I can indicate it there. This is R up to where? Up to here. That's range. Range R. Now, what is range? We shall say that it's a horizontal. It is maximum horizontal distance. Maximum horizontal distance from the point of projection to where the projectile lands the plane. From the point of projection to where the projectile lands the what? The plane. Lands the plane. Okay? Through the point of what? Through the point of projection. Then we shall now say that is horizontal motion, okay? That is horizontal motion. So along horizontal motion, horizontal motion, what happens? G is equal to 0. Because the body is not affected by G, is not affected by acceleration to gravity, or it is not moving under influence of gravitational pull, then U will be equal to, this is X, will be equal to U cos of theta, and this is constant, and is constant along the motion, constant, i.e. Ux is equal to Vx, which is U cos of theta. Okay? So if that's the case, let's substitute. We know that our y equals ut minus a half gt squared. So our will become U cos of alpha theta times time of flight, because the time taken is time of flight. So will become U cos of theta times 2u sine of theta divided by what? By g. So R will now become 2u cos of theta, okay, sine theta divided by what? By g. R. But from the trigonometry, U 2u cos theta sin theta is same as what? Is same as 2, sorry, but 2 cos of what? Sin theta is same as sin of 2 theta. So our range will not become 2 so to become u sin of 2 theta divided by what? Divided by g. Like that. Then we come back here. For maximum range, range becomes maximum when sin 2 theta is equal to 1. It implies that 2 theta is equal to 90, theta is equal to 45 degrees. So therefore, our range maximum will become u over g. U over g. That is our maximum range. U over g. I think there was, we made a mistake here. This is u squared, okay? U times u is u squared. So this is u squared, okay? So here to be u squared over g. Is that okay? Then from there, we are now going to look at, okay? We look at, okay, equation of trajectory. Equation of trajectory. Let me remove this one. Okay, let me remove this one. Equation of what? So we look at another diagram here, a sketch diagram, which is like this. Then I look at a point P, x, y, meaning that horizontally it is x, vertically it is what? It is y. Then the speed, this one is v, this is vx, this is vy, this is v, the arm is alpha. Okay? So we shall now say at that point, at P, we know that g is equal to 0. That means the distance x is equal to u cos of what? Okay, x is equal to ut minus a half dt what? Squared. So our x will now become u cos of theta times t. Where t is the time to reach this point, it's not the time for maximum. So our t will become x over u cos of theta. Then we shall now go back and say y is equal to ut minus a half dt squared. We now substitute. This is a vertical motion now, okay? So this is y will be equal to u sin theta times our t is x over u cos of theta minus a half gt squared, our t is x squared over u squared or squared theta. So meaning that our y is going to become u cancel, this is tan. So x is tan theta minus that is g x squared over 2u squared cos squared theta. So we can move this one. Then we shall now say but 1 over cos squared theta is same as cosec squared theta. Cosec squared theta. No, it is sec squared theta, which is same as 1 plus tan squared theta. So these are identities in mathematics, okay? So that means that our y will now become x tan theta minus gx squared into 1 plus tan squared theta divided by 2u what? 2u squared. This is the equation of trajectory. So to define trajectory, we say trajectory is defined as path described by a projectile. Path described by a projectile. Then we say path described by projectile. Then we finally say note. We are saying that at that point our Vx is same as Ux, which is U cos theta. Then our Vy is same as U minus Gt, which is same as Vy is vertical motion, so this is U sin theta times Gt times G, so minus G what? Gt, where we've seen that our time is equal to X over U cos over theta. Then we should now go back and look at examples. You look at what? Examples. Examples. So they will ask you to derive these things. Examples. Examples. You look at example number what? So we have this. This one says a particle is projected with an initial velocity of 30 meters per second at an angle of 30 degrees in the horizontal. Find the greatest height reached and then time to reach the maximum height. The final velocity before it hits the ground. When they say final velocity before it hits the ground, they are as well as telling us to give them direction because the velocity is a vector quantity. So in this case, we shall now say a particle is projected with initial. So let's say we have this. So the particle is projected like this. So it is with a speed of what? With a speed of 30 meters per second at an angle of 30 degrees. So here we shall have 30 cos of 30. We shall have 30 sine of 30. That is the vertical component of the velocity. So here, before hitting the ground, we shall have Vx, we shall have Vy, and we shall have this one as V. The direction is alpha. I call this one what? Alpha. So part 1, find the greatest height reached. So greatest height reached, of course we know you can either go through the steps or you can whatever. So you can say V squared is equal to U squared minus 2GH. So this is 0 is equal to U squared, that is it. 30 sine squared 30. Okay, squared here. Then minus 2GH max. So H maximum will become 30 sine of 30 squared divided by what? Divide by 2 times 9.81. If you want, you can quote. If you don't want, you can go through what? The steps. So the answer becomes. The answer will become. Let me see. What will be the answer? The answer. But you can use the calculator. You can use the calculator and get the what? The answer. Yeah. So our maximum, it's going to be. You can use the calculator. Let's use the calculator here. So that is 30 times sine of 30. Sorry, sine of 30 times sine of 30 equals squared equals divided by 2 times 9.81. 8 what? 81. The answer is 11.447 meters. Then part 2, time to reach the maximum height. Of course, we know our time. This is part 1. Part 2, time to reach the maximum is u sine what? Theta over g, which is 30 sine of 30 divided by 9.81. So it will be 30 times sine of 30 equals divided by what? 9.81. 9.81. So we shall be able to get 1 point. Time becomes 1.53 seconds. Then part 2, part 3, time of flight is twice what? Twice the time to reach the maximum height. So which will be 1.53 times 2, which gives us 3.06 seconds. Then the other one says the final velocity as it hits the ground. Okay. Next will be, that's in part 4. So Vx will become Ux, which is 30 cos of 30. What do you get? 30 times cos of 30. We have 25.98 meters per second. Then Vy is equal to Uy minus Gt. This is the time to reach the mark. But we don't have that type of flight because as it is the ground. So this will become Vy is equal to 30 sine of 30, okay, minus 9.81, and the time of flight, that's the 3.06. So here we shall be able to get that one as we shall be able to get 12.06 seconds meters per second. Then we shall now say the exact V becomes square root of Vy squared plus Vx squared. So when you substitute, you get your V as 28.64. 28.64. 28.64 meters per second. Then direction, alpha becomes tan inverse dy over bx, which will now become, when you substitute, you'll be able to get your answer as 24.9 seconds, 24.9 degrees, like that. That's number 1. Okay, we have number 2. A ball is kicked from a spot 30 meters from the goal post with a velocity of 20 meters per second at 30 degrees the horizontal. The ball just clears the horizontal bar of the goal post. Find the height of the goal post. So we have here, shall we say that this is the sketch. So this is the motion of the ball. Then we say the goal post is here. This is the goal post, okay? So at the distance x from here, at the distance x from there, then the distance, the vertical distance is y. Then here we have u. This angle is theta. So here we have vertical component and horizontal component. So they're asking us find the height of the goal post. So we shall now say, so we don't have the height of the goal post, but you can say that y is equal to ut minus a half gt squared. But our x is equal to u cos of theta times tan, right? Because under horizontal motion there is no g. G is equal to 0. So when I say half plus a half gt squared, that g is 0. So we shall now say that our t will become u cos of to become x x divided by u cos of what? Theta. So that means we don't have, there's a mistake here. There's a mistake in the question. Yes, okay, that 30 meters from the goalpost, so x will not x. So we substitute, our x is 30 over our u is what? Is also 30 times, no, our u is 20. The cost of 30. So our x will now become, our time, we're looking for time, 1.732. Time equals 1.732 seconds. Then we come and set therefore y will now become, this is u sin theta times t minus a half dt squared, which will now substitute and say y is equal to u, that is u is 20 sine of 30 times 1.732 minus a half times 9.81 times 1.732 squared. So when using calculator, we shall be able to get our vertical height as 2.61. 2.61 meters. So alternatively, or we could say y is equal to x tan what? Theta minus that is g x squared over 2u squared, 2u cos what? Cos squared theta. 2u squared cos squared. So we can use the equation of trajectory and you'll get the same answer. When you use the equation of trajectory, you get the same answer without necessarily getting the what? This. Now next is time of what? Flight. Our time of flight, we say that is twice. That our time of flight t is equal to 2u sin theta divided by g, which is 2 times u. Our u we said is 20 sine of what? 30 divided by 9.81. So what is our time of flight? 2.04. 2.04 seconds. Now if time of flight is 2.04, supposing they're asking us the time to reach the maximum height, what would be the time to reach the maximum height? Divided by what? By 2. The next says, how far behind the goalpost? So we have to get how far behind the goalpost. This distance, let us call this distance what? We call this distance A. Okay? So that we say that part 3, that x plus A should give us our range, not so? So meaning that our A will become our range minus x. But we have x, we don't have range. So our range is same as, remember say that it is u squared sine of 2 what? 2 theta divided by g, which will become, our u is 20 squared sine of 2 times 30 divided by 9.81. So what we get in the range? Now our range becomes So our range becomes what? That's a 400 times sine of 60 divided by 9.81. The answer is 35.3. So our range is 35.3 meters. So our distance will be 35.3 minus 30, giving us 5.3 meters. So meaning that it lands, where it lands the ground is at 5.3 away from where? From the goal post. So we got the next one. Let's look at a body projected horizontally from a spot of height y. Okay? The spot at a distance y from the ground. So it is projected horizontally. Just imagine this is like a fighting jet, which is thrown what? Missiles. Okay? So it is thrown at a horizontal distance. So at the horizontal it is given horizontal speed. So the horizontal speed It's given this one, which you can call u. But because of the gravity, it cannot keep in that motion. It will instead be acted upon by the gravitational pull of the earth. So along the motion, it will come like this. It will hit at a distance what? At a distance x from here. And as it is hitting the ground, it has the Vx and it has the what? Vy. Then it has the resultant, which is V, and the direction is theta, okay? So we shall now say horizontal motion. We look at two directions, horizontally. We shall say that we look at this one now. We know that that x is equal to ut by plus a half gt squared. It's a plus because it is moving downward, okay? But our g is equal to what? 0. So we shall now say that our x will become ux in our velocity. So our t will become x over u, this u, okay? Then we shall also go ahead and look at vertical motion now. Vertically, in vertical motion we shall say y is equal to ut plus a half, ut plus a half gt squared. But since the body was given horizontal velocity, it means that that horizontal velocity has no vertical component. It didn't have vertical components. But our uy is equal to 0. Okay? So that means that our y will become 0 times velocity by plus a half gt squared. So our y will become a half gt squared. Also, this velocity as it is hitting the ground, this velocity here, we shall say is equal to uy plus g what? Plus gt. But our uy is equal to 0 as we've already seen. So vy will not become g what? Gt. Resultant v will become this vy squared plus vx what? Squared r squared. But vx is equal to ux does not change. Does not what? Does not change. Does not change. Okay? Then we shall also say direction. Tan guru theta will become vy over vx. So theta becomes tan inverse of vy over vx. So how many questions? 1, okay, 2, 3. These are the questions that we shall be using when we are calculating. So we look at 1 or 2 examples. Okay? So they are saying that a ball is kicked horizontally from the top of a cliff 45 meters high. So this is 45 meters high, and it is given an initial velocity of 10 meters per second. And they are saying that find the distance x here and the time taken to hit the ground, and the final velocity as it is hitting the ground. The ground. So the velocity will have two components, the horizontal and the vertical component, and then you get the resultant of the velocity, and you go ahead to get the direction. So we shall now start like this. Now that's the time to reach the ground. We have the 3 questions. Y is equal to half gt squared, vy is equal to gt, and then we have x is equal to u times time. Now, which of those two ones can be used here? We have y, okay, so we can use that one. Y is equal to a half gt what? Squared. Because we said that uy is equal to 0, that's why the other ut is not there, okay? So we shall now say 45 is equal to a half times 9.81 times t squared. So our t becomes what? Using your calculator, what do you get as t? What do you get as t using your calculator? We shall have our t as 3.03. 3.03 seconds. Next is distance from the bottom. Now one distance x. So there's the other question which gives us x. So that is part 2. X is equal to ut. Okay? So substitute, which will become u is 10 times time. Our time, this is x. This u does not change. Okay. Under horizontal motion, the speed does not what? Change. Okay. U x is equal to v x is equal to v. Does not change. So times time to hit the ground is 3.03, which gives us 30.3 meters, and that is meters. Okay. Then next, final velocity as it hits the what? The ground. So we are saying that under horizontal motion, with Vx is equal to Ux is equal to 10. Does not change because under horizontal motion it is not affected by G. Then we shall now say under vertical motion Vy is equal to Uy plus, it's a plus because it is looking downward, plus Gt. But remember our Uy is equal to 0. It does not have the vertical component of initial vertical component. So meaning that our Vy will become 9.81 times time. Our time is 3.03, which gives us our U1 will now be our Uy under that component is 29.72. 29.72 meters per second. Then we shall say that V is equal to square root of 29.72 squared plus 10 squared, giving us the velocity is okay, you get the velocity, and then after that, after getting the velocity, here meters per second, and we say the direction theta is equal to tan inverse of Vy, okay, which is of 29.72 divided by 10. And this one will be able to give us 71.4 degrees. Okay, 71.4 degrees. So this is the exercise. We have this stone projected at an angle of 20. So this one is the same as the previous examples. This is a projectile fired horizontally from the top of the cliff. Find the initial speed so you don't have view. So you have to look at what I've given you and the three equations, and which equation can be suitably use it to fit what they have given us. Okay? You have distance x, you have the y, and you're looking for u. Which of those three can give you u? And then you're looking for what? You're looking for velocity of projectile as it hits the ground. So here our vx remains the same as initial. Then the vy, you have to calculate vy. Then you need to get the what? The direction. Then here, the bullet is fired from the gun, pressed 200 meters. So the gun is pressed somewhere. So if the projectile is pressed at some height, then when you're using y, you use y as a negative. You understand? Because as it is falling down, it will fall down below the level where it was projected from. So use y as what? As negative. Is the point clear? So use y as what? As negative. So here you use y as negative.